In this problem, we got this guy that's pushing on this piano and he's pushing upwards in this direction. The force I'm going to call capital F, trying to keep it from speeding up going down here. So he's going to keep it moving at constant velocity, moving in this direction. So we're going to have a displacement that way. And we're also going to have friction that's going to help him. So we got some friction working upwards. So the first thing I'm going to do to sort out what's going on here is draw the free body diagram. So here's the piano, and we of course have mass times gravity pointing straight downwards. We have the normal force perpendicular to the incline. We have friction parallel to the incline upward, and then we have the guy's force, capital F, in exactly the same direction. So I bring in my axes, I put in the y-axis through the normal force and the x-axis parallel to the incline like usual. And I notice that I have this mg vector is not flat on an axis, so I need to figure out what this angle is. And I see that that angle is this angle up here, right? So the angle of incline was 30, so this angle here is 60. So now I'm ready to write equations. The x equation is minus friction, because it's to the left, minus the force of the man pushing, which is also to the left, plus mg cosine 60. It's plus because this force is to the right. It's cosine because I'm doing the x equation. And this has to be equal to 0 because it says in the problem that the man is going to keep the piano from accelerating. That means the acceleration is equal to 0. We can also write the y equation, a little bit easier. Normal force minus mg sine 60 equals 0. And we know that F equals mu n. So the first thing they ask you is to calculate big F. Well, from here I can see that big F is equal to mg cosine 60 minus the friction, just by moving things around. And I know that friction is equal to mu n, so that's mg cosine 60 minus mu n. And I know that the normal force from here is going to be equal to mg sine 60. So that tells me that for part A, the force that the man is pushing with has to be mg cosine 60 minus mu mg sine 60. Okay, I think that's the hard part. From then on, all we're calculating is work. So for part B, they want to know the work done by the man on the piano. Well, that work, the work from the big F force, is going to be the big F force that we just calculated times the displacement, which they gave us. And if I put the displacement in this diagram, the displacement is going to be this way, right? So the angle between these two forces and the displacement is 180. So this here is going to be force times displacement times the cosine of 180, which will make this whole answer negative, which makes sense. The next one is the work done by the frictional force, work from little f. So that's going to be the frictional force times the displacement times cosine 180. It's the same angle because they're pointing in the same direction. And I know that the friction force is equal to mu mg sine 60, this thing right here, right? So this is mu mg sine 60 times the displacement times the cosine of 180, which is just minus 1, that part. Then part D asks for the work done by gravity. So for this one, we're going to be looking at this force and this displacement, and the angle between those is 60. So the work done by the weight is going to be the force of weight, which is mg, times the displacement times the cosine of 60, because that's the angle between the displacement and the weight force. And that gives that answer. And then lastly, for the net work, we're just going to add up. The total work is going to be the work done by the man's force plus the work done by the frictional force plus the work done by weight. And remember, when you add those up, some of them are negative, and you need to put them in here as negative.